solution for private LTE and how it relates to the educational market. I'll give you a little bit of background on Baicells and the solution that we're offering, and then Jay will take over, kind of get into the nuts and bolts of the technology, and then, like Max mentioned, we'll have a Q&A at the end of the presentation. Next slide, please. So Baicells Technologies is a global organization. We are a small cell manufacturer by trade, LTE and 5G and R. We are in networks across the globe with both indoor small cells, outdoor small cells, high power, low power, and open RAN solutions, and leading into 5G new radio as the technology is coming. In the United States, we are in more than 600 networks to date. A vast majority of those networks are using CBRS technologies and also EBS, but mostly CBRS in fixed wireless access. Those two frequencies are going to be key for the educational broadband solution that we're going to be talking about here. Just to quickly touch on our partnerships as an organization, a couple I wanted to highlight: Multifire, the Facebook TIP project, Open RAN Solutions, Open RAN Alliance, and these are the standards bodies organization, the CBRS Alliance. We are not only members of these organizations, but we are contributing members. So these are the standards bodies that are creating the technologies that we're using today and on into tomorrow's 5G. So it's important that as a company, we not only are building off of the technologies that have been created, we're actually part of the standards bodies that are creating these technologies and then delivering them to you. We are a public or a private organization with an array of investors, which include Qualcomm Ventures. Qualcomm has actually invested multiple rounds in Baicells, including the most recent round of nearly $16 million specifically for development of 5G technologies. So we have an array of investment partners. The purpose of this webinar is how do we address what's happening today with COVID-19? All of a sudden, students are having to start the school year that is starting now, actually, in many cities. They're having to start the school year remotely. They can't get into the classrooms. How do you keep your students online? Part of the problem there too is how do you prevent your students from doing other things, watching Netflix when they're supposed to be in class? So we want to actually not only extend the existing network on the campus, but bring it out to the neighborhoods and reach those students in their homes so they can actually be in the classroom. But how do you do that when the technology we're using today, Wi-Fi, that can handle the campus environment, it can't reach out into the neighborhood. It can't reach out to the rural areas that are miles away from the school. So we're going to go through this presentation and we're going to touch on each of these topics: the coverage, the range, funding, security, ease of installation and management. So as we kind of go through this, we'll talk to each of these bullet points, and again, at the end, we'll go through the Q&A. I mentioned Wi-Fi, and I'm not going to talk too deeply on this particular slide because Jay has a similar slide where she deep dives into the differences in the two technologies. So I'll leave that to Jay, but I did want to use this as kind of an entry point because school districts are very familiar with Wi-Fi. Every campus has Wi-Fi. You're very familiar with it. It's easy to install. It has a vast ecosystem. Devices all have Wi-Fi. Wi-Fi access, so it's simple to use and it's well known. But you also know the problems that come with it. It's not secure. You don't have the range that you need, and being in unlicensed frequencies, you are subject to interference. So the more access points in a concentrated area, the more retransmissions you're going to have, and which degrades your potential throughput and transmission. So there's the issues that come with the unlicensed technologies in Wi-Fi. So the pros of LTE, you get a dedicated channel. When you're transmitting, that's your channel. You're not subject to outside frequencies. Specifically, as we talk about CBRS technologies and EBS frequencies, EBS is fully licensed. You own that frequency. There isn't another operator out there that's going to be in your airspace. So you're not going to have the issues that you have in 2.4 gigahertz and 5 gigahertz unlicensed frequencies. So we'll get into that a little more detail later in the presentation, but I wanted to just kind of touch on, we understand Wi-Fi as it relates to the campus environment, but then as we move further out from the campus into the neighborhoods, how we utilize private LTE and in CBRS and EBS frequencies. Kind of as I mentioned, we just took a little bit of a snapshot on how this is going to look. So the campus, you see the campus Wi-Fi, you understand that, you reach out to the students' homes. The student homes, the neighborhoods are typically within a couple of miles of the school itself. CBRS frequencies, which is 3.5 gigahertz, using a MiFi device or an indoor CPE, or even a laptop in an outdoor environment, you may be able to get up to a half a mile away from the transmitter from the school with that type of CPE. But then we also have outdoor user devices that can mount to the side of the house, or even go in a window and aim towards the transmitter, the school, and get somewhere in the neighborhood of about 3 miles away, depending on terrain, of course. If there's hills and trees, things could be affected. But then using EBS frequencies, which is 2.5 gigahertz, fully licensed. In CBRS, you're allowed 47 dBm power output. So for us to have a maximum power output in that frequency, we have a radio called the Nova 436Q. The Nova 436Q is a 4x1 watt radio. So a 1 watt per port radio is able to get you about 3 miles from your school or transmitter location. With EBS frequencies, our products, the Nova 243 and 246, are 10 watt and 20 watt radios. So you can imagine, if you can get 3 miles away from the transmitter in CBRS, how far out could you get with EBS? What could you do with that? Well, now those handheld devices, the laptops, the MiFi devices, well, now you can be miles away instead of within a half a mile, or using that outdoor high gain CPE, mounted on the side of the house, you can reach out into the rural areas, very far from the base station, the school location. So this is just a quick snapshot of how we layer in the private LTE in those various frequencies. This I just wanted to show you because this is an actual coverage map of what we did using CBRS, our Nova 436Q. This is on the left, this is actually the rooftop of a school, and you can kind of see all the surrounding neighborhoods that need to be covered. And it's from this school, everything falls into that red area where you are getting full throughput, top modulation rates. And I did a measurement all the way out beyond where the neighborhoods are. And you can see in this upper box, we're at 2.5 miles out to the edge of full modulation. So if you were to, kind of swing that around, you're covering this entire neighborhood surrounding that school. And this is with the CBRS frequencies, where our radio is a 1 watt versus EBS, which could go much greater distances. I'm going to let Jay take over from here, because she's going to kind of get into the nuts and bolts of LTE versus Wi-Fi. So Jay, go ahead.
Yep, thanks, Bob. Hello, everyone. This is Jay Lewis. I'm the Director of Sales Engineering. I mean, Bob just touched on from high level on a few aspects for LTE technology in general. So here I'm going to give a more of a end-to-end from solution perspective, a holistic view as far as what LTE solutions includes, and especially when it comes to deploy a LTE network and what aspect we need to consider. So what are the steps? So before we get into that, again, we get back to the LTE and Wi-Fi comparison. The reason we keep doing that, because we understand, especially for schools, you know well Wi-Fi technology, and you all deploy Wi-Fi on campus and in stadiums and all that, and you all know Wi-Fi very well. So LTE, why we Bob mentioned LTE, the coverage is better and it penetrates better. And why is that? It's not because we are LTE vendor. It's because from technology perspective, and Wi-Fi has some technology limitations as shown here. So I don't want to get into details as far as what RSSI, what RSRP is, but in general, here what we're trying to show you is from a Wi-Fi technology perspective, it takes a better or stronger signal in order to get connectivity for a Wi-Fi network. And on the other hand, for LTE network, as long as it has a bare minimum RF signal, and it can allow a much worse RF condition to enable an LTE connectivity. That's why what we are showing, what we are ending up with is Wi-Fi mainly used on campus and short range coverage, and also it only mostly provides line of sight coverage, means straight line. And instead, LTE is more used for one area network coverage, as well as a short distance coverage. And also when it comes to security and Wi-Fi, we all know when we get access to a network, we require a password. We call it web authenticate based. But for safeguard, we call it safeguard based, EAP based authentication. It's a much more advanced authentication method. So it enables a much more secured connectivity from LTE network perspective. So that's why LTE is considered globally a robust technology for not only for not only local area network, but also wide area network, LAN and WAN, as well as the public, as well as the private network. So here I want to just talk a little bit about if a organization like a school deploy a LTE network, what aspect we need to talk about, what things we need to address before we really comes into deployment, specifically for schools. And number one is frequency. Of course, all these aspects apply to all companies, all operators, but I'm going to just talk about mostly from school perspective. And as Bob mentioned, as already mentioned, band 41, CBRS, 5 GHz. The reason we talk about these three frequencies is only because these three frequencies are what we see the most available to EDU customers. And we all know band 41 in legacy, it's many schools actually owns it, and although many of you guys sublease to Sprint, and or just sold it. But we know that there's a number of opportunities coming up to allow the schools to reacquire the band 41 frequency. Number one is we know there's a band 41 spectrum auction that are coming up by Q4 and maybe Q1 next year, because there might be some delay. So, and for this auction, of course, Indian tribes and schools will have some privilege. So we know some of the schools that we're working with, they actually, right now, they are applying for SPA, required experimental license, just to start a trial site and to get some field experience. And also once they deploy something in a specific frequency at a specific location, very likely when it comes to auction, they will be likely to keep using that spectrum. So that's one thing. The other thing, I don't know how many of you are from California. In California, we know that from T-Mobile and Sprint acquisition deal, and Sprint actually agreed to divest some of the Band 41 spectrum and to schools and other tribe organizations. Some schools are actually been applying spectrum from Sprint and for some of their spectrum in local area in the region. So that's something you can, if you are in California, you may want to look into if you have interest to pursue this. And that's Band 41. And Band 48, the reason we talk about it, because we know CBRS, it's a tier-based license, and they have 3 tiers, and then the last tier, which is GAL license, will allow anyone to have access. So it's have general accessibility. That's why all entities have the right to use the spectrum as long as the interference is properly managed by the SAS central database. So for schools who do not have Band 41 spectrum, so CBRS can be a good option. And of course, we have our unlicensed 5 GHz, which has been occupied very much by Wi-Fi network today. And so, but if you want to, expand further your Wi-Fi network to cover the further distance, and we have the solution. We have LTE solution that works on unlicensed spectrum 5 GHz as well. So for this 3 spectrum, and as I listed here, Band 41, again, it's an auction license. You have to either own it or lease it. But once you own it, you have the privilege to use it within 30-mile range. So there's a minimum interference that need to be worried about. So and most likely it's going to be for Band 41, it's going to be 50 plus 5 MHz arrangement. So you will need, if you don't get 2 or more carriers, you will likely to use a 50 MHz rather than 5 MHz. And because it's a lower frequency, so it can transmit a lot further than the higher frequency, like 3.5 and as well as 5 GHz. And also it penetrates a lot better in a non-line of sight environment. So all in all, if you get to use this spectrum, that's a way to go. There's no, second saying. And of course, if you don't get to use that spectrum, CBRS is a way to go. As Bob mentioned, we've been working with many customers and wireless SP as well as other verticals and schools on CBRS network deployment. It has some limitations because of the FCC transmission power limitation, 1 watt per 10 megahertz, and also because it's higher, it's a mid-band frequency. Comparing to Band 41 and even lower 700, 900 megahertz, it has limited capability when it comes to RF penetration. But consider its availability, its and affordability. You can use GL license free of charge and anytime, and starting from actually March this year. So it's a very good opportunity for EDU to start an LTE deployment and using CBRS. And of course, 5 GHz in some cases, if it's for backhauling or just for some pure line of sight deployment, it can be utilized as well. It got its niche market or niche use case scenarios, if that's a way to say it. So yeah, that's just a brief comparison. And again, when it comes to school LTE deployment, if you get to use band 41, perfect. If you otherwise CBRS. And of course, in many cases, one thing when we work with schools, most of the school deployment are capacity driven per site. There's like 700-800 students they need to serve. So very unlikely you will have enough bandwidth on band 41, even if you own it. So now overlaid approach is actually a most efficient way to go as well. Just a band 41 deployment overlay with the CBRS deployment. And so the CBRS can absorb the traffic, the students that are located nearby the site, and while band 41 can allow long-range extensive coverage.
Yeah, and one thing to comment on, as Jay mentioned, you can overlay, 5 gig, 3.5, and 2.5, however combination that you want to mix and match those, but it's all the same element management system, the same CloudCore. So everything from the management standpoint is universal across all platforms. Our software platforms are the same across all platforms. So from a management standpoint, the network doesn't register it as one technology versus another. So just for the ease of management. Sorry, Jay, go ahead.
Yeah, I will mention that when it comes to product. Yeah, definitely. The second thing we need to consider is site selection. So the way I listed here is really the prioritization. Number one, you have to have spectrum, can decide which spectrum you're going to use. Number two is site. We know when it comes to tier one or any mobile company operators, they have cellular tower. It's easy for them, but for schools, and most likely what they're going to have is a 2-story stadium, a high school building, maybe a light pole that we can use. Yes, but those are maybe challenging for the micro base station deployment, which are those funky, big carrier class base station. But for our solution, I will show you later, which is really a SoC system on chip based, a small cell form factor base station that we can allow the base station, just mounting on a light pole or mounting on the wall or rooftop or any kind of vertical structures. We will allow those kind of deployment scenarios. So when it comes to site selection, so any vertical structure can be considered, as long as there's power, there's backhaul, and also, of course, if you get to the higher the better. If the rooftop is 2-story, if you get to install 15 feet mast to make it 40 feet and total, that will be better, because typically it's the antenna goes to the higher the antenna goes, the further penetration it can get. That's just applies to all wireless technologies. And also, when it comes to deployment, we need to make sure that sometimes when we work with schools, they say, okay, well, we have a water tower, you can use a water tower is 50 feet. I say, hey, perfect. Then we did our simulation. Then we realized that, the 50 feet water tower, the top 10 feet has been occupied. We have to really, all we can use is from 40 feet down. Then there's segregation. All we can use is like 30 feet. So we need to make sure that the height, one thing is the height of the vertical structure itself. Number two is where can the, equipment antenna can be hanged. So we need to make sure we work out on that. So, and ideally the small cell, the base station need to be hanged as close with the antenna as possible to eliminate unnecessary the jumper in between, so there's no penetration loss there. The other thing you need to consider when it comes to site selection is what we noticed that school, there's, because for instance, elementary schools, they're all close together, right? Like less than 1 mile, there are different elementary schools. They said, okay, each elementary school, we can use their buildings, but they are like all less than 1 mile apart. Then we need to work with you to do some, selection, whether we use this one or versus the other. They are potential candidates for sites, but we need to do some planning and engineering study to decide which one to use in order to get better and make sense coverage and the best service for the students. So those are things we need to consider for the site itself. And number three, when you deploy an LTE network, we need to understand what kind of service you want to deliver. Is it just you really want to have the network to extend to cover the school students that are underserved and in the rural to allow them to access internet at home, or maybe some schools actually say, hey, we have school bus. We want students. It's a long drive. We want the students be able to do homework here when they ride in the school bus, so they don't have to spend an hour doing nothing. So that's a completely different use case, if that's a way to say it. And also, there's some are, just very on campus, not in building, but on campus. They said, oh, right now in building we have Wi-Fi, but our campus, especially college, is kind of big. We want, just on campus, so students, when they walk in the campus, they can have free access anywhere they like. So those use cases, we need to understand what kind of use cases we're talking about, because those use cases, number one, will decide the device form factors. Number two, will decide when it comes to our studies, we need to make sure that if it's it's just a fixed application or a nomadic application, or maybe it's even mobile. You want mobile, it can work with their cell phone. And I will talk about later, so what it takes to enable the roaming to the public network, the cell phone public network. If that's something you decided to go, we will tell you what it takes. But our solution are mainly focused on fixed and nomadic applications, and we don't provide full mobility, which means we don't provide solutions that enable roaming with tier 1 carriers. That's something else. And also, we need to understand, because when it comes to wireless ISPs that are in rural area, most of them are like more coverage driven. They want to cover as many as residential houses as possible, because they are, number one, they're sparsely populated. Number two, they want to maximize the ROI. And but many times that we found when we work with school, the students, it's more capacity driven, as I mentioned. The students are not far. They all located in the area, but there are hundreds, even thousands to be served per site. So when it comes to network design, these two are completely different considerations. So we need to understand. We will discuss with you then, and going through all this, then decide which way to go. Then we design the network. Next page, please. So this is an end-to-end LTE network architecture. And again, for this webinar, we are really trying to do from a high level or holistic view to explain what LTE network involves and what it takes to help you build an LTE network. If you need any detailed information, we can always, feel free to ask during the Q&A session, and also feel free to reach out to us. We can discuss detailed, technology details or anything you're interested in of session. So from the solution perspective, as we know for LTE, there are mostly three portions. Number one, we call it core. Core is, we call it 4G EPC, and it's actually involves packet core. And EPC is basically, we call it the brain, right? It controls the network and it establishes connection, then to make sure that data traffic goes to the, being filtered and goes to different places, that kind of thing. And then we have the RAN network, radio access network. Radio access network are the ones that are required, be hanging on vertical structures. Then and all the traffic be backhauled to the, the central office and to the core 4G LTE core. And of course, for backhaul solution, if you have fiber, perfect. And in some states like California, Utah, you already have a, EDU, a fiber network in place statewide. That's ideal. But sometimes, you maybe just have gig Ethernet network or just a wireless microwave or 5 gigahertz point-to-point, that will work too. So, as long as there's enough capacity to allow the traffic being backhauled to the backend office if needed. And then we will have device. Device is for different market segment, and the needs are different. Again, for instance, wireless SP, they love those outdoor base station that with extra high antenna gain, which allow them to do rooftop mounting and can go far. But for students, because students are mobile, you go to elementary school, you are down 5th grade, you graduated. So for schools and and one concern is that they want the device to be as portable as possible. So we will talk a little bit later. We have different form factors of device, but it is really depend on what frequency you have, and so we can work with we have proper product to device to work with talk with bees to enable the connectivity. So, and of course, and to manage the overall network, as Bob mentioned, we have the network management system. We call it OMC. So then, next page, later on, I will discuss all these elements one by one. So start with base station. Base station is really part of the radio access network. So we, based on the frequency, and we have the base stations that work on band 41 and CBRS, as well as 5 gigahertz. For outdoor base station, what we're showing in this portfolio specifically, you can see that specifically Nova 243, 2x10 watts, Nova 246, 2x20 watts are the ones that are working on band 41 EBS. Then we have Nova 227, which is a macro pop, is 2x250 megawatts. Then we have Nova 233 and Nova 436Q, which is 4x1 watts. Those are the ones that working on CBRS frequency. So again, based on different scenarios, for instance, if it's you only have you have just pocket, you have a gap coverage or a pocket you want to cover, you only like 10 students, and then you have then we can use the 227 CBRS just to get a handful of students and to get them to the network, provide active connectivity. And of course, if you're talking about the very heavy loading network, you probably want to use the dual carrying enabled base station, which is for CBRS is 436Q and for EBS is 246. And this 2x40 watts is FDD solution, which is more of a cellular frequency. So again, as you can see, our solution are SoC based. It's all small cell based. So when it comes to installation and deployment, it's plug and play, very simple. You don't really have to worry about structure engineering, the heavy load or the potential weight that can cause any issues, engineering issues to the vertical structures and so on and so forth. It's very simple. When we provide a solution, all the mounting kits, GPS, they're all included. So all you need is really antenna and jumpers, but then the REM part is it's all done. Then we have indoor base station. Indoor base station is really, indoor coverage is really driven by CBRS. In CBRS Alliance, they define 4 different use cases, and indoor coverage is one of them. And we know that especially for schools, now indoor coverage are mostly just done by Wi-Fi. I mean, for long term, in order to enable the seamless connectivity and all that, if you have the outdoor EBS or CBRS LTE coverage, and very likely if you have the indoor LTE coverage as well, it's just one device for all. So that's just something to maybe that's just a future thing to consider, or step 2 thing to consider. But yes, for indoor coverage, we have specific solutions for that as well. And specifically, our newest product is we call Neutrino 430. It's right now it's in trial. It's 4 by 250 milliwatts. It's now indoor CBRS LTE solution. And this is LTE-U. This is what we mentioned, EBS, CBRS. This is 5 GHz solution. In LTE, when we have a solution work on 5 GHz unlicensed, we call it LTE-U. It's, yes, LTE unlicensed spectrum. So as you can see, this is a very compact design. It's also 5 GHz, and it's LTE-U will it also works on 5 GHz, same as Wi-Fi, but when it comes to penetration, it penetrates better than Wi-Fi and go much further than Wi-Fi. And the other thing is our LTE-U is actually FDD based rather than TDD. If you know the terminology at all, FDD is more of when it comes to uplink and downlink, you use different spectrum. This allows the solution to provide uplink spectrum up to 75 megabps. So we see customers use it, sometimes use it for backhaul solution, and sometimes we do see the factory automation application. With line of sight, we see them use this solution as well. Just to give you something in your pocket, when you find a site and you don't have backhaul solution, this might be an option for you to use. And yeah, we talked about the frequency. Typically, when it comes to wireless technology, any wireless technology, the lower the frequency is, the further it goes. And the higher the frequency is, the less penetration capability it has. But very likely, so the higher the frequency goes, very likely you can get a huge amount of the spectrum. That's why 5 GHz, right? Now we're talking about 28 GHz millimeter wave. And why? It's not because it's better than lower frequency. It's because it's you can get abundant spectrum on the higher frequency, because historically all the existing deployment are mostly based on the lower frequency. They are already pretty much occupied. So that's why when it comes to specific band 41 and CBRS, because band 41 has a lower frequency, so it allows extensive coverage, as well as it allows more of a nomadic applications. And then it translates into the device form factors, which means for band 41, and the students use like portable devices like this MiFi device. And also we will have a band 41 Chromebook become available to allow them to go to different classrooms and to get the remote learning of the content they are needing for the class, that kind of thing. And of course, and traditionally, and for band 41, we will have the indoor CPE, then outdoor CPE, and hiking and logging. And that this is more for residential installations, and students that are underserved, don't have internet at home, they bring one of this home. If it's indoor, they put it on desktop. If it's outdoor, they install it on rooftop. And for CBRS, very likely, I mean, when we work with the schools, we're just being honest, and very likely you will need an outdoor hiking CPE in order to get certain distance, like Bob mentioned, 3 miles, and very likely based on the terrain, the earth condition, and a number of factors. But more than likely, you will need an outdoor CPE to be installed on students' home and rooftop rather than a indoor desktop modem type thing, just because of the frequency limitation, the technology limitation. It's not the solution limitation. As you can see, these two, certified, we know that for all CBRS solutions, both CBRS Alliance and FCC, they are going through all, the certifications. All of our CBRS solutions are either being certified or are under certification. So these two form factors are available for CBRS as well, and they are both CBRS certified. And also we have a PoE router. So this PoE router is designed for this kind of indoor CPE. It has a built-in Wi-Fi, right? You put on the desktop, and then the students can use Wi-Fi to access to the service. But for outdoor CPE, you will need one of those PoE routers to be connected to the CPE. Then PoE router acts like number one, will provide power to the CPE, and also it actually integrates with CPE to allow in this case, it's not the students, to allow the IT director or technical staff of schools to staff of the schools to access the PoE router to troubleshooting the CPE. But on the other hand, it acts like a Wi-Fi router. And again, as I mentioned, when it comes to site resources, one is backhaul, the other is power. And it's good that you already have the power in place. In some cases, if you want to use a light pole, or there's not enough power that for the LTE deployment, then we do have an outdoor power supply as well as a battery backup solution, and to allow the quick, new site acquisitions and setups and installation. And this is, then now we talk about the RAM part, right, and the base station. We talk about device part. Now we talk about core, EPC core. And core, we said it's a brain. And the brain really doesn't matter what frequency, as Bob mentioned, doesn't matter what frequency of technologies as long as LTE. And the fact is, one beauty of LTE is because it's a 3GPP standardized technology. It get the global ecosystem, and so it's really vendor agnostic. So it's as long as it's standardized, the interoperability can be achieved at many levels. So specifically for core, Baicells is our company. We are the first one in North America introduced a CloudCore solution. We actually hosted a CloudCore on Microsoft Azure. We have one on the West Coast and one on the East Coast. So the CloudCore what it does is we talk about an end-to-end solution. We need a device, need base station, and need core. But core, compared to the rest of the network element, and number one, it costs more, and number two, it's require a level of daily maintenance from technology perspective. So the CloudCore will enable any operators or entities to get an easy start. Just you can buy one base station, get it set up, and then you have the access. You have device to access the network that's using our CloudCore, and the CloudCore costs $1 per device per month. So if you know the LTE technology at all, they will say, hey, then this way you will haul all of the traffic, data traffic, students' video and homework traffic to the CloudCore. Then it requires huge bandwidth, and that we actually took that into consideration. For our solution, all of our base stations have an embedded local gateway, and actually all the data traffics are localized between base station and the CloudCore is really mainly just the signaling traffic. So that requires minimum bandwidth there. Also, along with the CloudCore, there's EPC, then there's OMC. And if you use the CloudCore service, you will have your own UI, user interface to get in to manage not only your base station, but also your devices, all the devices. You to check the students use the devices, their status, and also do the basic troubleshooting, so on and so forth. And during the, once we deploy the CloudCore, then we have customer on board. Then we found out one thing is connection between base station and CloudCore. We call it S1 connection. Then it requires high reliability. Basically, the backhaul. If there's a extra latency or there's disconnectivity, or the service at the customer side and user side are impacted. So for this kind of situation, we actually introduced Halo B. Halo B is a feature that is to be deployed as a light to be deployed on each base station. It basically allows once a student to try to initiate the first connectivity with the CloudCore network, and Halo B license will download the student profile, the user profile from the CloudCore HSS to local base station. Then if later on there's a sudden disconnectivity for the backhaul S1 connectivity, then students will maintain his or her connectivity and still doing whatever his homework or his remote learning session. The service won't be impacted. So that's one thing that's very needed for the CloudCore, this kind of deployment. And we know that for many schools that you need content filtering system like iBoss, and it doesn't matter if CloudCore or here we have local core, it can be implemented at base station level. Also, if you later on introduce a local EPC, have all on-premise solution, it can integrate with the local EPC as well. It's all being deployed with some of the customers. So of course, and because it's students, some schools they're large and they have thousands of students, and also they want a better control of their network. Some of the schools say, hey, I want my whole network shut down at 10 p.m. every day, so students won't surfing in the night or can't get up the next day. And so then in this case, they can have their own on-premise, we call local EPC and local OMC plus /BOSS. In this case, they have an end-to-end on-premise solution, and so they have full control of the network. And also, local EPC will introduce some additional features comparing to CloudCore, like better improved QoS and so on and so forth. And so the approach is, if you want to start a trial network, it's very easy to set up just one base station to use the CloudCore. Once you feel comfortable and ready for the massive deployment and decided to go with local EPC, and we can easily smoothly transit you to a local EPC, so you can have an end-to-end solution at your location. This is we call it NMS. It's actually it's just an operation and maintenance center. If in your network you already have a NMS, our solution can be used. The EMS can provide northbound interface to interconnect with your existing network. Otherwise, it can be used as an NMS by itself and manage not only base station, EPC, as well as device. And this actually is one thing because most of the LTE networks, and when it comes to management system, they have two different management systems, one for infrastructure, which is base station and EPC, the other for device, they call it device manager. So for our solution, as we are a private LTE solution vendor, we understand, a scalable solution, start from small and make scalable to a larger or mid-sized solution, network. So we actually combine the two network elements into one. So you can basically use this one OMC to manage all the network that on your network. That's actually one beauty of the network. That's the end-to-end solution. So before we get to why Baicells, I want to touch one more thing. As here's a, I told you what it takes to deploy a network, and here's a, each network element that is needed. Number third, many schools after first conversation, they will ask then how to move forward. What should I do? And very likely when we work with schools, we will, help them identify a few potential sites or vertical structures that can be used as a tower site. Then they will provide us the students, targeted students locations or underserved students locations. Then we will discuss on the potential antenna height, what kind of applications, use cases, what kind of, based on the frequency they have, then device form factors, and based on all those inputs, and we will provide a, our planning service. I will do our planning service for them. And based on those inputs, we will use our simulation to output basically a heat map to say with this size and with this, each side, with this setup, how many, this particular model of base station at what transmission power, use what antenna model, can reach how far, and this far, and at what location students use what kind of device can very likely get access to the service. And with this setup, how many students can potentially be covered. And of course, we will generate, bill of material and quotations, and for you to do evaluation, and then you can always start a POC. And actually, because of the COVID-19, there are many cases that, there's money, you don't use it, you lose it. So many schools, they just, purchase all of the equipment that are needed for the network. Then they use a phased approach for deployment. That we do that as well. We start with the, one or two sites, then to see how they're going, because when it comes to school, logistics is a big thing. There are so many students, how you hand out devices, how you work with parents, that kind of thing. So that's a phased approach will be make a smooth, transition as well. So anyway, so to sum up, why Baicells? It's, again, we are private LTE solution vendors. Based on, we use standard, standard technology. It's a global recognized, technology. We can, our solution can work with any other standard device or solution as well. So we are not really proprietary and locked down, one solution only type of thing. So, and also as you can see, our product portfolio is very tailored for the small to medium networks, like for vertical space like EDU, especially for schools. We have MiFi, Chromebook, indoor, outdoor CPE. I haven't seen any vendors that have a full product portfolio like what we do. And CloudCore. CloudCore is a very key advantage from, just from word of mouth from our customers, from, WISP and EDU, as because it's just allow a minimum investment to start a quick launch and the service, and so without really a heavy overhead, upfront investment. And also, we know many EDUs, they want one-stop shop and turnkey, and we can do that with our partners. And also some are already have, actually there are a few schools, they already have experience deploying WiMAX network. They have, hand-on experience. They are, they only want a particular base station only or device only. We can do that as well. It's really, we can work based on your requirements. And again, I believe this year we've been we worked with at least we deployed actually at least I would say a dozen of EDU networks, both band 41 and CBRS. So what we have extensive experience working with EDU market segment, and we so we know that schools and they have some unique concerns, and also some of the deployment difficulties. So we do work with them around all those things as well. Anyway, so that's pretty much an overview from the solution perspective.
Jay kind of touched on some of the financing options that are available. Do check with your, there are state and federal programs that are available. We've got a couple just highlighted here with E-Rate and the CARES Act. The CARES Act is offering some financing options for educational distance learning projects. Those must be submitted for funding by December of this year. So as Jay mentioned, we can, get the ball rolling. We can do a phased approach and get all the hardware ordered and in place with a phased deployment approach. So you can take advantage of and leverage the funding, even though you may not be able to hang every single radio ahead of the expiration date. I believe that takes us into the Q&A section. Max, I haven't been monitoring that, so if you want to just go ahead and ask some of the questions that came in.
Absolutely. Yeah, I know we're at the top of the hour, so we'll try to get through this quickly. The first question that came in was, what do we do for MDU distribution? Yes.
For MDU, yes, actually, that's a very good question. The many schools we work with, because underprivileged students actually live in apartments, and for those, we can actually, the solution we recommend is use that outdoor device and mounting on, use one or two mounting on each floor, then use like a Wi-Fi router thing to connect to do the indoor in each apartment space connectivity. So there's, yes, we do have the schools that have special scenario like that. But again, if you have band 41, that will be better if it allows the, more penetration from outdoor to indoor. Otherwise, we can work with you on the indoor coverage design as well.
Yeah, and when we went through our portfolio, we've got the outdoor radios, but we also do have indoor radios, the PoE router, which you can actually have the outdoor CPE mounted to the building and then radiate Wi-Fi in building, or we also do have the in-building CBRS radios. So depending on what that multi-dwelling unit requirements are, we can tailor a solution.
All right. Next question is, how far does the band 41 MiFi unit operate outdoor and indoor?
That's a very tricky question. And first of all, between indoor and outdoor, we know the wall, there's 10 dB penetration loss, right, straight there. So for MiFi, we do see the customers that can go as far as 2 miles. And still with acceptable service level and downlink uplink throughput, but there are some challenging spots. For instance, we do see some schools that are the site they picked is actually not on top of their elevation. Terrain elevation is actually at the bottom of the terrain, very unfortunately. So there's some challenging spots, and so there's 1 mile, and we don't see a good service. So it really depends, and we really need to do a detailed ARC study with you based on the terrains or environment you have in your school district.
And the elevation of the base station equipment is a factor in that, as she mentioned earlier. We've talked to some schools where all they can do is, put the radio on top of the facility, and maybe they can get an extra 10 feet on a mast, but it really only puts them at 30, 35 feet. So the higher the better as far as range and penetration.
All right. Another question is private LTE an eligible expense for E-Rate?
I can't definitively answer that question. We can certainly research that and get back to the question asking purchase party.
Absolutely.
So, I just saw some. Again, Bob is right. We are not on authorized organizations to speak for that. But I just saw some news, right? Because I work with schools so closely. and their school, at this time, E-rate only cover on-campus broadband deployment, not off-campus. So LTE is not covered by E-rate. However, I know there are teachers and there's some organizations, actually there's 7,000 teachers, they actually sent the invitation to FCC to request and for future to request LTE to be considered to be included in E-rate. And it makes lots of noise at this time. And right now we don't see any firm reply from FCC or any other regulation bodies. But I do see the momentum is there. But yearly, we don't know. It takes a long time for regulation changes or updates. So you never know.
All right. If there's any further questions, we'll take them now. I know we're at the top of the hour, a little bit past that, so we're kind of out of time here. I would just like to thank everybody for joining us here today. If you have any further questions, feel free to reach out directly to Jay or to Bob. Otherwise, you can also send an email to sales_na@baicells.com. We do have contact forms on our website as well, just to make it easy if you want to reach out via that method. But we're always looking to talk to people, answer the questions, make sure that we can really get these products out there and begin building these networks so we can get distance learning for these school districts. Like I said, thank you everyone for joining here today. Bob and Jay, do you have any final words before we're done here?
Just thank you for your participation, and we look forward to engaging with you going forward.
Yep. Thank you.
Perfect. Thank you, everybody. I hope you have a good rest of your day.